Hello and welcome back to the series. Last time we had just finished getting all the plan forms laid out and figuring out where everything needed to be to get the CG in the right place. Today we're going to be doing the lofting of the aircraft. Essentially we're going to define all the exterior surfaces of the aircraft. So this will include the wings, the canards, the vertical stabilizer, and the fuselage. I'm going to start just with the canards and the vertical stabilizer, just getting them to the correct single sheet of foam thickness, which is 3/16 of an inch in this case. Now is also a good time to start putting in your control surfaces. So for this rudder here, I'm thinking probably something about this big should be reasonable. And that's just basically eyeballing it. As a general rule of thumb, if you can get about 30% of the area of whatever tail feather you have as a control surface, then that should be pretty good. I'm not going to draw anything on my canards because they'll be all moving, so the entire thing will be the control surface. Airfoil selection doesn't matter too much when you're at the model scale, unless you're doing some really high performance stuff. In this case, I'm just going to use a Clark Y and then modify it to suit my needs. The major parameter you're looking here is just thickness. A really thick airfoil will get you a decent amount of maximum lift coefficient, and then the thinner you go, the less maximum lift coefficient you can get, but the less drag you have. So there's sort of a trade-off there. Also, the thinner the airfoil gets, the harder it'll be to support structurally. I want a decent amount of maximum lift coefficient out of this aircraft, but not too much, so I'll probably end up going around an 8 to 10% thickness. So I'm just gonna draw out my airfoil here real quick. Alright, so that looks to be a reasonable approximation of a Clark Y. And it's got a fairly small amount of points, which will help because I'm doing this by hand. So basically what we want to do is get the airfoil at each point where the taper begins. So if you have an elliptical wing, this will be really hard because the taper is continuously variable. But if you have a wing like this where it's just straight tapered there, basically you're going to want to have an airfoil section here and here, basically on the parallel edges of whatever trapezoids define your wing plan form. And so then you're going to want to scale these to the chord of the wing. And then if you're building with Foamboard, you're going to have to correct for the fact that the minimum trailing edge thickness you can get without doing any beveling is 3/16. So basically we add one of these, and then go back to the next point on the foil, and then that's your modified foil. This one here looks like it's actually greater than the thickness of the foil itself, so this will actually give it a bit of washout because the trailing edge will be higher than the leading edge, which is good. That'll help the span-wise lift distribution and help prevent tip stall. So now we can get rid of this plan form here, and then basically just loft between the points on these. In better CAD programs, there's probably an automatic way to do this, but basically you're just matching up every point from this foil to that foil. And you'll be able to do that fine up till the point that your modifications of the foil start to interfere with that. So here basically we're going to end up putting all these to one point, or maybe this one to that point. You can see that this one is sort of curved like that, so I'll probably end up going like that. Then this is concave in here, so we'll probably move that from here to there. Make sure we don't have any concave sections. I think this one could stand to be this way actually. And that looks pretty good. The more points you do this with, the more accurate the skin will be to the actual final result of the aircraft, but this should work pretty good. Again, better CAD programs would probably do this with as many points as you like automatically. Then we can smooth this out. And if you'll notice, our trailing edge is a nice 3/16. It's flat all the way across. Now I'm not going to add the Elevons into this because I don't know how big the fuselage is going to be, but we'll just take this and copy it. And that's our wing lofting done. You know, the more I look at this, the thicker I think this wing is than it should be. I'm probably going to go down to like 6% thickness or something. I'll do that real quick. So now I can start to think about my fuselage shape here. I think what I'll do is I'll just try and sketch something up in paint and see if it looks good. Something like that seems alright for that view. Something like that looks pretty cool for this view. And then that looks pretty good for this view. So now I'm going to go ahead and try and translate this into CAD. So 100% of the fan swept area for this ducted fan is 4.9 inches squared. For the main inlets, I want to be a little bit over that, not too much though. So if I do maybe 20% over times that 4.9, that's going to be 5.88 per total, divided by 2 is 2.94 inches squared per side. So that's what we'll work to here. So with these, I want to take them down to the bottom plane of the wing, so that the bottom of the inlet is going to be basically flush with the bottom of the wing and the fuselage. So that's 1 3/8 there. Take off 3/16 for the foam board width there. Take off another 3/16 this direction. So that's going to be the corner there. And then this will come across, well, we figure this is 1 3/16. So we take this divided by 1.3/16 is 1.875. So that 2.5 inches. If we did that on both sides, we wouldn't have any width for the fuselage there. So we're going to have to move this up so that this inlet can be more square, so that we have width for the center fuselage here. And we want this to be at least the width of the battery plus 3/16 on both sides for foam board. 2.95, 2.94. So that's dead on what we want right there. Actually, you know what I'm thinking of doing? I'm going to keep it like this, and I'm going to make this taller up to there, and then I'm going to move the wall out until I get to there. Because what that'll do is it'll make sure I've got space for a battery strap in here, basically. Although I guess I could turn the battery this way if I wanted to. Turn it vertical. We could actually change the spacing of these canards in or out. That's another option too. I think we could move them out like maybe 1/4 of an inch or something. So I'll go ahead and do that. So now these guys are 3.125. We wanted 2.94, so we could probably take it down a bit more. So I think if we take it down 1 more 16th, it should be pretty much right on 120% FSA. So that's basically 17% over 100% FSA. And keep in mind, we'll have the cheater door, so these will only really be under full load at high speeds. And then we'll have the thickness of the foam go into here and all the way up to there. Just a quick lesson in ducted fan terminology. I'm saying FSA. What that means is fan swept area. So there's going to be this area here, which is the area that's occupied the motor, and then the blades will be going around in this area here, and then this will be the diameter of your fan from here to here. So this will be like 70 millimeters or whatever it is. This will be the diameter of the motor, and the fan swept area is referring to this area right here, this annulus of area. So in the case of my ducted fan that I'm using for this project, this area here is 4.9 inches squared. A good rule of thumb is that your outlet area is going to be around 90% of this. Less if you want more thrust in the air, so more dynamic thrust, but that'll give you less static thrust. Optimum static thrust is typically at around 100% of the fan swept area in terms of outlet diameter, but you don't get as much dynamic thrust with that. Typically the trade-off depends on how good your ducted fan is. Better ducted fans will be able to go lower on the outlet FSA and get you higher dynamic thrust. Typically around 90% is a safe bet for most EDFs out there. So that's probably what I'll be using on this one. In terms of the inlet area, typically you want 100% or maybe a little bit more, especially for cheaper EDFs, or if you have a really long inlet duct like I'm probably going to have here. Basically that's just because when you stick a long inlet duct on front of a fan, the thrust goes way, way down because it's not very good at pulling air, but it is good at pushing air. So that inlet restriction doesn't help it out. So you want to, if you have a really long duct, you want to make sure the inlet is oversized a bit to help compensate with that. So anyways, that's our little ducting area there figured out. So then this will be the side of the fuselage. This will be the plane that defines the side of the fuselage there. This is basically our top surface of our inlet there. And then our inlet will come back like this and do whatever it does back here. So now basically what I'm going to do is I'm going to create a profile representation of these drawings in CAD. All right, take that, copy, paste, put the two halves together, and there's our general shape that we're looking at. Looks fairly similar. So I'm basically going to figure out where the cross sections of this need to be. We'll have one there, one there. All right, so those all should be straight up. This is the CG line. There we go. So that's what we want. So now I can go over here, and we can start drawing this. And we'll try and use these points that we have here. And you don't have to use every single one of these. Like, you know, I left this one out here. But it's better to not use all of them than to have to add more in. That's looking fairly close to what we drew out there, I think. I'm looking at that and it looks pretty good. All right, now we have our profile and plan form view of our fuselage. So the next step is to isolate the fuselage itself and start to make the cross sections. We'll have to choose what the inlet ducting does here. All right, that looks pretty good. We'll do the same thing for this guy. And then we'll have to find the intersection of those guys. So it looks like we need a couple tweaks here. You can see the ducted fan is sticking out the side there, and then the flight controller here is sticking out the side as well. I'm also looking at it, and I think I need to probably make this a bit further close to the aircraft. Just looking at this here, this line could probably come more this way inboards. This top part could come out a bit, and that should get us what we need in terms of getting clearance for the flight controller here. That looks pretty good there. Although I would like maybe these to go in a bit more. You can see this, between these two faces here, this is a pretty straight line. It's almost completely, they're almost completely straight, and then this one bends a lot more. So if I move this one back, it'll be a bit more gradual of a curve here. That looks somewhat reasonable. Could do that on the other side. There we go. Could also probably move these guys back a bit, just to help that out too. Minimize the angle change, the angular change in there. Yeah, that looks better, I think. All right, that's looking a lot better. Here's something I want to consider too. I probably won't end up doing a box fuselage on this. And so since foam can only be curved one way, these are going to have a cross section that goes around like this instead of having a curve here. So I won't be able to have this curve if I want to have rounded fuselage sections. So I'm going to have to get rid of these guys here. And then I'm going to probably subdivide this and probably blend it into this bottom surface more. And that's a bit more gradual of a curve than the original template here. All right, if I were doing just a basic box fuselage, this is probably the point I would stop, but I want to add some curves in here to show you guys how to do that. So essentially what I'm going to do is I'm just going to find these cross sections, and I'm going to draw the rectangles of the cross sections. In fact, I think most of them should already be there. Yep, they are. So basically I'll cut away everything that's interconnecting those cross sections so we get just the rectangles left and the point at the tip here. So now we've got the cross sections of our fuselage here. And what we're going to do is we're basically going to start to round over the corners and the edges on this stuff. So I'm thinking about how I want to do this. I think we'll start with this bottom corner that runs from the nose all the way back to the inlet here. So we'll start by defining basically what we want the radius on the bottom to be. I think up here it's basically going to be a continuous radius, sort of like a circle. And if you're doing this in something like SketchUp, you'll want to take note of how many segments are in this circle here. So it looks like we've got 6. So all of the other radiuses we do on these next pieces will have 6 segments, and that'll make it easy when we go to combine them together and skin everything. So I'm actually going to draw to the center line of this for each one so that we only have to do 1/2 of it. So at the very point here, at this point, I want this to have 0 radius because I want this bottom part of the fuselage to be square. Because if we had some sort of radius in here, the inlet wouldn't be flush with the bottom surface of the aircraft. Basically, I want this entire bottom surface to be flat. And the way of doing this without extending the fuselage down so that I could get a radius in something like that is to essentially just make this radius here 0. So the radius here is about 3/8. We have 2 formers in between, so I'm just going to say, because we want the radius to be 0 here, so this is 3/8, this will be 2/8, which is 1/4, radius here will be 1/8, and that'll get us a somewhat smooth transition. They're not equally spaced, so it won't be perfectly linear, but it should look pretty good. I think we'll actually keep this one up at 5/16 here, since it's actually closer to this one. So that was 5/16, so this is going to be somewhere between 5/16 and 0. We'll call it 3/16. Just stay on the big side. And that's still a really small radius, it's just the thickness of the foam. So now we'll give this a shot at connecting everything. So in SketchUp, what we do is we basically just draw a bunch of lines between here to create a bunch of triangles or faces between each former. So you can see this is basically a section of a cone right here, and that creates the radius all the way down to that point. We could smooth that out with the eraser tool by holding Control. There you go. And so now we'll extend this forward. And essentially what you're doing is you're drawing between the corresponding points. This is why it's important to, if you can, have the same number of points in each one, because that means that this point here goes to the first one on this radius, this one goes to the second point, and so forth. If you have an uneven number, you'll end up with some panels that aren't square like this, or that aren't, I guess, parallelograms. You'll have some triangles in them. And even with these parallelograms, there's no guarantee that they'll be in the same plane. So you might have to make up two triangles like this to get a parallelogram to form. And when you do that, you want to make sure, if it's wildly out of plane, that it's convex and not concave. So that looks all right for a radius there. And then we'll just finish that out by bringing it all to a point at the very front here. All right, so that looks pretty good. Now that I'm looking at it, this radius here could probably be a little bit smaller, but there's not much we can do about that. I'm just looking at this line here, and I want this line to be concave the whole way up, but here it goes from concave. If it was concave, it would be up here, but it goes a bit convex. But I think that's probably close to the best we'll get it. I think we should actually do the canopy first, because this will have to meet up with the canopy no matter what it does. And currently the canopy is, you can see the canopy comes all the way to the edge of the former there, so we would have to have square sides if we were going to do the canopy like this. And we do have to maintain clearance for the battery and stuff here, so I don't think we can put much of a radius on these. So I think we'll keep the sides of the fuselage flat actually as best we can, except for up here, because we can start rolling them in, at least until this part on the canopy. So that means that basically these parts of the fuselage here are going to be square. I think we'll start with the canopy first so we can get a good idea of what the radiuses are going to look like on there. So this will do the same process, just isolate these formers here. So with these, we're probably just going to end up with some sort of simple shape like this. We'll increase the number of segments. It'll be just sort of like a circle-ish shape. So I'm looking at that. I sort of like it a little bit, but I think it would be better if this was a bit non-circular. So I think what I'm going to do, because I want it to bulge out less, essentially what I'm going to do is I'm going to do the same thing, but I'm going to end up squashing these. Or actually, I think I might have to do it the other way around, because this is going to increase this to stick out on the sides. So I think I need to go to 0.8 first and then to 1.25 to scale it back to the original size. It's not coming out over the edge. Now, it might bit on this middle former like I did last time, but it's not nearly as much as last time. So I gotta do that to this one. And then I can scale these back up to the original height to get the profile the same. And of course, the reason why I'm using 80% in the 1.25 is because 1.25 times 80% is 1. So they're just the reciprocal of one another. And so if we go and grab our original canopy here and bring it over, this should be fine with the, the profiles match here, you can see. So now that we have these, we can loft between these. So it's pretty much the same process. And here, they're not in the same plane, so we're going to have to draw triangles between them, but we'll hold off on doing that until we've got all of the points matched up. Because sometimes when you're doing triangles, it can be sort of hard to figure out which points match up with which and so forth. So loft between the points, and you can make sure that all the lines are straight and they're not crisscrossing like this. It's easier to see that with just all straight lines instead of having triangles everywhere. So for this one, you can see that this back part is such that if we want to have a convex surface, we're going to have to do that. So if we did this way, we'd have a concave surface here. And you can see that here. So that's a concave surface. And then if we did it this way, this is a convex surface. So this is what we want. And basically, we're going to do that all the way around. All right, so those are two elements of our canopy together. Now, if we wanted to, we could just make these taper to a single point, but that's not quite the best. It would be cool if we could get some sort of curvature going on it that would come out like this. And that is possible, so we'll have a go at doing that. So go ahead and scale this guy. Should be able to select that bottom point there, yep, and free scale it all the way. And when I do that, does it come outside? I think it just barely does, actually. Or no, it barely doesn't. That's perfect. I think I should actually do it more because we want to get a bit of a radius on here. So 5/8 will go down to maybe 3/8, get that shot, make sure it's on the correct plane here. So this one, maximum curvature is going to be dictated by this line segment here, projected all the way out. So that's about 1/8 of an inch. So that'll be a good start to whatever curvature we do there. And we could curve it more than that. It's just that when that happens, this part of the cockpit will overhang whatever is beneath it. Which, I mean, a little bit of that is probably okay. We might go for like a 3/16 radius in the corner here. That would look pretty nice. All right, and there's our cockpit. So next is going to be those radii here. I am going to undercut it a little bit. I think I'll actually go up to full quarter just to try and get a good bit of radius in here. Yeah, so that looks okay. I sort of wish that this triangle here came to more of a point so that these sort of bounding lines, because you'll see these a little bit on the actual plane, these sort of bounding lines weren't concave on the outside here, and they just were convex all the way in. Ideally, I mean, we're looking at it from this side, there would be more radius down here. And I think we'd actually do that by scaling this radius vertically. So if we highlight this, we can make more radius in this direction, or we can make it further down in this direction without being further down in that direction. So we'll scale it by like factor 2.5, and that looks a lot better. But it still keeps that overhang rather minimal, because we haven't moved the radius in this direction, it's only been in that direction. In fact, I think I can use that technique to get these radii and make the flat panels, the concavity of it, work out better. So the more I look at this, the less I'm liking this little corner here. And so I think I'm actually going to try and taper to the bottom of this, if that's possible. So we'll see how that ends up. Now, this is going to be complicated by the fact that we have this in the center here, so we're going to have to deal with that as well. All right, so that looks a lot better. I think actually, I'm looking at this line here, I think this line, I would like to have the cockpit, I would like this part to be convex here, so the cockpit to come up more like this. And I think the way of doing that is if we hide this, we can try and rotate this guy down a bit. And we'll move this down a little bit. Do about 2 degrees maybe. And then unhide the other one, and then the geometry should adapt. And of course this, the rest of this came in here because I unhid everything, but that looks better. So there's a bit of a ridge going up there. And we're going to start to work on the aft section of the fuselage here. And I mean, we could like maybe curve it up here, but you don't really want to do anything concave here, because doing concave exterior surfaces in Foamboard and making them look good is generally pretty hard, because you want the paper to be on the exterior surface of the aircraft. Basically with Foamboard, you can't really curve foam unless you remove paper from one side of it, and the side of the paper that you remove is always the inside side of the curve, so it's always the concave side of the curve. So if you were going to try and do a smooth curve with something to sort of maybe curve like this or something like that with the inlet, you would have to have bare foam on the outside, and that's not good for durability. It's also not good for looks. So the only way to do that really is to do a bunch of score cuts in the foam and then break the foam on the other side. And then you could end up with something like this, but you'd always see the score cuts through it. Whereas with something like this, I mean, I can subdivide it into, I think these are 12 equal segments, and it'll turn out looking like it was pretty much continuous because it adapts the shape of the former below it, and it sort of rounds its own surface out. That's the thing with these, is I'm not going to cut every single line that's in this canopy. I'm just going to take these sheets as they are and then roll them onto the formers, and it'll turn out to be a very smooth surface. So that is one of the limitations we have to look out for. Now, as far as the bottom surface here goes, because that doesn't have to mate with the canards, we can probably put some sort of radius on that. I actually want to unhide this so I can see where the main gears, or the main wing starts to come in with this, because we don't want there to be that much of a step between the main wing and that. I would want the radius to sort of meet the leading edge of the wing. So just eyeballing that, we probably have about maybe 3/8 of a radius here before it starts to meet the very leading edge of the wing here. And really with a radius this small, it's not going to make too much of a difference. You could even get away with just having this as a simple bevel, but it does definitely add to the look of the airplane. That looks pretty slick. So we'll bring the wing back in there. And then this is what I was talking about with the radius sort of meeting the leading edge here. All right, and then the interior here, obviously this is going to be, I think this is going to be flat pretty much all the way in. But then after this is where we can start playing with larger and larger radii. So I think I'm going to go on the inlet side first and just sort of hash this out here. And again, if we keep the wing in here, you can see that I don't have to do anything with the bottom of the fuselage. Because the bottom of the fuselage is flat with the bottom of the wing, any radius which I do here doesn't have any significance really. So I'm looking at that and I'm thinking probably about this much. I mean, we're going to have to keep in mind that there's going to be thrust vectoring geometry in there too. If I wanted to, I could also start maybe putting a bit of angle downwards on these. That might help out. So around there should be the edge for the radius. All right, so that's looking pretty good. And then I want this to basically start to come down, this line from the back of the canard, Or maybe it should start coming down before that, actually. I think I could make this radius a bit bigger. Maybe about that big? Yeah, so this is starting to go down here, but it's also tapering in this direction, you can see. Or it's sort of slanting. Maybe getting a better angle for sort of joining with this part of it, I guess. I mean, that looks pretty good there. You can see on the wing, that looks pretty good. Now we've just got to do the radii there and whatever sort of twisting we're doing with the inlet to blend it in better. So then we can loft between these and then play around with the scaling so that it looks somewhat all right. We also want to consider this line here, going from here. Because you can see it's this inflection point here I think is a bit harsh. Because basically we're going from, I'm thinking about this, we're going from square and then we're tilting these lines here. We're basically tilting them outboard. You can see those. So maybe this should be more tilted outboard. Or it's about the same. It's a little bit more back inboard. But maybe we do something with this last former here that makes it a bit better. I mean, looking at it more, I think this point here is a bit too high. Definitely. So we'll move that down a bit. That looks pretty good, actually. I'm going to put in these other faces just as flat faces to see how it looks. Alright, so that looks a lot better from this top perspective. Looking at these panels here, that taper is pretty gradual. I like that sort of constricting down here and then it gets bigger towards the end. I'm noticing here that this is sort of a high point on the fuselage. So we might be able to bring this one up a little bit to sort of smooth out that top curve there. Yeah, that looks better. A lot of this is really just subjective. You know, you sort of look at things and see if it looks right, and if it doesn't look right, you change it until it looks more like what you want it to look like. Speaking of which, I'm going to try and bring this guy down a little bit. Yeah, that looks a little bit better. So now that's left is just this this razor back here. Figure you look at this, and then this line could probably come maybe to here-ish. Chuck that in there. So that's looking pretty good. We're going to want to pay attention to this line right here. I'm going to try and keep that concave down for this whole thing. I'm also thinking on the back here, we want to keep this square, or I would like to keep the square. So at the front here, if we draw this line here, this is basically the midpoint between the two. I think I want 3/16 or a foam's width on each side of the vertical stabilizer here. So we're probably going to put 3/16 up here, and then it'll come out to the square edge there. And then we can put whatever radius ends up going on here. Alright, so I think that's about it for the fuselage, actually. So before we finish this, there's just a little bit more we need to do. First is going to be just getting these landing gear figured out. We're going to add some aerodynamic coverings on these to help reduce drag. Give it a, I think the last time I gave it a clearance of 3/16 around the wheel here, so we'll do that here again. There's 3/16, somewhere around there-ish. Oh, yeah. So at the front here, these are going to be our full width of the tire, so that's 3/4. And then at the very front here, we're going to take it down to 2 foam thicknesses, so that's going to be 3/8, and then that's going to taper. I think I'll actually try and take it down to 1 foam thickness at the back, because that'll be good for drag. All right, and now all that's left is just to extrude these guys into themselves, intersect them, and then we should have our, basically our solids there for the gear pants, for the main gear. Alright, so we got that. Take these, and then make another one of these, offset it to the other landing gear. So now I just got to do one of those for the front. Alright, that looks like what we need. Alright, the last thing I want to do is get the control surfaces on the wing. Initially I was going to end up doing some slats, but upon further consideration I figured I probably just only need Elevons. Slats are probably a bit overkill for what I need to do, and I think they're just a bit of extra complexity seeing as we already have thrust vectoring and stuff. So I'm just going to put in some Elevons on this one. Now that I'm looking at it, I think these might be a little on the small side. And I also think I'd like to have just an inboard section, so get rid of this wingtip section. So I think I'm going to shorten the span. We're going to have like a little wingtip section here. And then also these are going to get more chord on them. So if I do everything right, that's probably what it'll end up looking like. So that's it for this episode. We've got a lot done. We got pretty much all the exterior surface of the aircraft done. All the lofting is done. So next episode, we're going to start looking at how to do things structurally, and we're pretty much going to flesh out the internals of the aircraft. Till then, I'll see you.